Hi, so my name is Tiba. My student ID is 2005455. So I'll be explaining the background for this household gas monitoring and leak preventing system. So first of all, gas usage in homes. Since long time ago, natural gas and LPG have been used worldwide for not just cooking but also for various purposes. While natural gas and LPG are very abundant in resources and everything, it also has some safety risks which can leak. For example, the gas in the tank can leak, and this is a gives a safety hazard and can cause for some dangerous explosion and fires. So in our system, what we are trying to do is that to use modern solution using sensor technology as well as IoT frameworks to enable accurate gas reading as well prevention system. And in this system, we have two parts of it. And first is safety, and then there's conservation. For safety, we'll be focusing on how to prevent hazardous situation such as gas leaks and fire and so on. While for on the conservation part, we are trying to detect on how to promote sustainable energy usage. So for the sustainable energy usage, it will be driven by data-driven optimization, where we'll be using the precise consumption data from the homeowners to optimize energy usage and as well like replenish supplies timely. And for the future prospect, what we can say is that this system or technology is still evolving, but one thing is that it promised to transform the household energy usage and management to a better perspective in the future and better option, not just in terms of safety, but as well as conservation, allowing for a better environment. And that's all for the background. Thank you.
Now I will present about three of the problem statements. First, lack of preventing system. At present, there is no notable absence of a dedicated prevention system. The existing monitoring system lacks the capability to proactively prevent potential tragedy. For instance, the system without automatic gas tank shut-off switch or proper ventilation can cause explosion if the gas concentration reaches maximum. Secondly, lack of real-time monitoring. The lack of real-time monitoring poses a significant challenge in ensuring the safety of gas usage in households. Currently, many gas systems rely on manual or periodic checks, which are prone to oversight and delay in detecting potential hazards. Without continuous monitoring, it will become difficult to promptly identify issues such as gas leaks or abnormal pressure level, increasing the risk of accident and tragedy. Last, gas leakage rely on human detection. Currently, the detection of gas leak mainly rely on individual noticing the smell of gas. However, this method has limitation. For example, if there are no people nearby or if someone has a weak sense of smell, the gas leak may go unnoticed. This reliance on human detection can lead to delays in identifying the leads and responding to potential danger, increasing the risk of accident. Then the objective. Three of the objectives is to build a gas leak detection system. The system may utilize the sensor capable of detecting the gases and analyze the gas concentration level, triggering the alarm or notification when abnormal readings are detected. Secondly, to detect the change of temperature surrounding caused by fire. Utilizing the temperature sensor, the system can detect the rapid increase in room temperature beyond predefined threshold, signaling potential fire incident. Such detection capability is crucial for early fire detection and prevention measures. Thirdly, to provide a real-time gas monitoring system. Real-time monitoring enhances situational awareness and allows for immediate response to gas-related risks, ultimately enhancing overall safety and security. Our proposed solutions will be shown in this AWS architecture diagram. First, we will create three sensors: temperature sensor, gas concentration sensor, pressure sensor, and then these three sensors will register in IoT core. And then the data received from IoT core will store into Amazon DynamoDB. The Lambda is help to read the data from DynamoDB and then query in the Amazon Athena. After that, I will use the Amazon QuickSign to generate the graph, and then another Lambda function is created to trigger the SNS function and send the alert notification into the email. After that, use an API gateway to connect the application and AWS Cloud, and use another Lambda function to process the user actions and send the instruction to IoT core, so the IoT core can perform actions into Windows sensor and gas sensor.
Hello, my name is Leong Yongqing. Now I'll talk about comparing the cloud providers. The two cloud providers that I'll talk about is Amazon Web Services and Microsoft Azure. Firstly, the Amazon Web Services has the largest market share of 32% as of 2023 quarter one. As for the Microsoft Azure, they are the second largest market share, which is 18%. Then both of them has use the pay-as-you-go pricing model, and for their operating regions, Amazon Web Service operates in 32 different geographic regions around the world with 105 availability zones. Meanwhile, for Microsoft Azure, they have 60 plus announced regions. They are more than any other provider in the world. Besides that, Microsoft Azure has a lot of strengths. They provide seamless integration and transition with Microsoft Enterprise software solutions, such as Office 365, Windows Server, and more, such as Visual Studio and others. This is because Azure is under Microsoft Corporation. Amazon Web Services is popular with business of all sizes. Meanwhile, Microsoft Azure, they are more towards enterprise focused.
Hello sir, my name is Yong Hui Ting. My student ID is 2006076. The part that I want to present today is future trade of gas monitoring system. Rapid development in gas monitoring system with future trade focusing on intelligence and efficiency. Evolution from traditional equipment to IoT and AI-based intelligence system. Intelligent gas monitoring system equipped with advanced sensor and algorithm for real-time monitoring of parameters like gas pressure, concentration, and temperature. Data are routed to the cloud for analysis and storage, enabling seamless integration with other smart devices and applications. Predictive analysis and automated control feature detect potential gas leaks or anomaly and take necessary action like send emergency notification. It enhances in efficiency and accuracy, reducing the risk of accident. It also can customize service and solution tailored of different user needs and application scenario. Application extend beyond home to various workplace like catering industry, factory, and laboratories. Examples include ensuring safe gas concentration and pressure in kitchen, and proactive monitoring harmful gas leaks. Overall, future trade of gas monitoring system aim for comprehensive improvement in technology, functionality, and user experience, ensuring safer and more efficient gas monitoring solutions across industry.
Now I will demo how we set up inside the AWS console. First, we will go to the IAM service to create IAM user for each group member. Assign the administrator access for all members so that they can use all the service. So after we successfully add the member inside IAM user, they can check the email to accept the invitation link of IAM user. After that, we can continue our task. I will create an IoT core by search IoT core in AWS console, and then connect device, type the sensor name, and then follow the step on AWS IoT core, copy the command, and paste inside the command prompt window to make sure the communication pinged successfully. In this assignment, I choose Python as my programming language. A connection key zip folder is directed, which includes the certificate, key, and SDK, and PASAP code. After that, unzip the zip folder and put inside your folder. So I name it as gas sensor folder, and then inside the gas sensor folder, we have the cert, private key, public key, policy, and then a start file. We can run the start file using the PowerShell. After we run the start file, it will send a message to the SDK test Python hello world. We can check the message inside the console just now. The expression name is SDK test Python, and then the message is hello world. After make sure the message published successfully, so I can start to modify the code to generate my dummy data. For this assignment, I will use the visual code to modify the code. First, go to get sensor start.ps1, change the topic into your topic, and then go to parsup.py to modify the Python code so that you can generate the dummy data and send to IoT core. Go to your sensor AWS IoT core device, and then inside the sample folder, you can see a parsup.py file. So you can change all the code here to generate your dummy data. So this is my code. After that, go to IoT core, and then security policy, edit the sensor policy to make sure the policy allow your topic to publish message to IoT core. Then copy all the policy in JSON format and replace into the policy file just now that downloaded. Now we can start to run our code in Visual Code. For the assignment, I run the code file in PowerShell. If you show the sensor connect to AWS successfully, then the message start to send to IoT core. So this is the example. The message sent gas concentration equal to 99.53, and then every 1 second will generate a new data. Then you can go to MQTT test client under AWS IoT core, type your topic here, and then click subscribe. You can see your message just now. After that, we need to connect IoT core to DynamoDB. We can choose the rules under IoT core, and then create rule, type your command, and then create DynamoDB table. Key in all the information here, and then you can go to Amazon DynamoDB. Under the DynamoDB, we can create the table, and then you can show the table here. And then click inside the Explore table item. You can see all the data stored in DynamoDB.
In my AWS workflow, the part that I need to do is use the Lambda to put data for dynamic DB and execute query in Amazon Athena. Then I use the CRUD site to visualize this data and create comprehensive chart, DPT, calibration, and gas reading. Now we do the Amazon Athena first. First, we create the last query editor to do the Amazon Athena, and it will display this page, and we need to create the data source. And inside the data source, it does not show any data source, so we need to create the new data source that we want. And I create the Amazon DynamoDB to be a data source, and fill in the information of the data source. And now we need to create the Lambda function to connect the DynamoDB and Amazon Athena. Now we go to the AWS Lambda. In the Lambda, we need fill all the detail of the Lambda function, and you need to create the space package. The space package is set the query output of the Amazon Athena. We go to Amazon S3 and create a new package, and fill all the information of the package, and name the package name is Group1 data package. And I need to copy the name and paste in the Lambda and copy the information, and then I click the deploy. And it successfully create the Lambda function. And now we need to copy the link of the Lambda function just create and go back to the Amazon Athena and paste the link of the Lambda function and click the next button. Then we click the data source button. Now the Amazon Athena have DynamoDB data source. When we go back into this page, and we need to find the DynamoDB data source that created before, and it will show all the table of DynamoDB are already created. we can test this can run query of the table or not. It successfully created data. So now we go to the quick site. The quick site is ensuring other people can easily understand the meaning of the gas monitoring. First, when we go to the quick site, we need to sign up for quick site and choose the edition that we want. I choose the enterprise. And then we need to create the quick site account and fill all the information that I need. Then I need to choose the Amazon S3 so I can get the data into the quick site. I need to get the permission of the Group1 data package and then click the finish button. It already successfully to create a quick site account. So we now need to go to the Amazon quick site. We can create the new analysis button. First, we need to create the new database first. I choose the internal to be my dataset. Now we need to name the data source and create the data source. I have 3 data sources, which is gas TB source, pressure TB source, and the temperature TB. Now we need to choose the package that will get the data source, which is Group1 data package. And then we select the data that I can visualize and click the edit or preview data button. It will show the what data I have inside. If I want to add the new data, we need to create the add data button. Then we need to add data set inside. I choose the pressure dB short and the temperature dB. So we select these 2 data source and create the select. And you need to join the data source with the join type of inner. We will show all the data set that include. Now we can start to visualize the data diagram that we want to show. This is the visual diagram that I want to show to the people. The left side has shown the increasing or decreasing of the temperature, gas pressure, and the gas concentration. And the left side is show the maximum of gas concentration and minimum gas pressure. It will show the percentage of the increasing or decreasing of the gas pressure and gas concentration. In the right side is all the information of the temperature, which is maximum temperature, average temperature, and the minimum temperature. The table under the right check is the dataset with all the level 1 information. So that's all that I done in the AWS. Thank you.
So first of all, for my part, I'll be creating a function for the detector. And in this case, we have a detector. This lambda function works to query the sensor data from the DynamoDB and then check whether the readings are exceeding the threshold. And if it exceeding, then it will send a SNS alert. So in order to create this lambda function, it's very easy. You just need to press this button here, create function. And then author from scratch, and then the function name. And for choose the language that you want to use. For this one, we use Python 3.12 and then the architecture. And then at the bottom here, we have the create function. So once the function is created for this one, you can see the diagram. We have a DynamoDB 3 in here specifically the trigger because we have like from the gas, the table, temperature table, and then pressure table. And then we also have the SNS to produce the SNS notification. And here we can see the code. And then there's also a test function which I will use to show whether it's working or not right now. But before that, I will show the SNS on how to create. This is Amazon SNS. So the first one will be to create a topic. So here, once the topic name is entered, and then you choose whether it's like first in, first out or standard. For this one is standard. Once the name is entered, then you can put a display name, is an optional one. And then you can create a topic. And once the topic is created, it will be shown here at the topics. And for this one, the topic is called leak alert. And this ARN will be used to trigger the SNS notification, which here is in the code is put the lambda here at the bottom. So this ARN is important because without this ARN, the SNS won't be sent or won't be triggered. And then once the topic is created, subscription, here you can see, but subscription need to be created. Where again, choose the topic, for example, leak alert, and then the protocol. And for this project, we use email because email is easier for the receiver, where they can receive in multiple devices, not just in like SMS. SMS will be like only like one device, even though you can add multiple, but email means one single email will be sent to all the devices. So for the email one, once you created and enter the email, the details to create a subscription, you need to enter your email and verify, because it will be showing as pending confirmation. And then once you click on the pending subscription, it will show confirm. The status will be changed to confirm. Now I will show how the Lambda and then the SNS works together. So here we have test cases. So if the code is triggered, the Lambda function is triggered, it will show this status code 200 and Lambda function executed successfully. And for this purpose, we have a SNS notification set because it's a high temp alert. The test event we can configure based on the timestamp we want, based on the DynamoDB, and then we can save it and then test it. And just now we use for high temp. So if we check the email, and here it is AWS notification, it will show alert gas leak is detected. Temperature is above the threshold. The current value as well at what time the timestamp is detected. If the user wish to unsubscribe, they can just click on this link and will unsubscribe. And that's all for my part. Thank you.
And this is the part that I'm in charge of. There will be a mobile app, and user can use the mobile app to remotely open the window or switch off the gas. To receive this mobile app request, I create an API gateway, and then the API will trigger AWS Lambda, and this Lambda will process the request and then send the command to the relevant window sensor or gas sensor based on the body of the request. So first, I create the things, gas valve sensor and house window sensor. Then next, I create the Lambda function, remotely control things. I create function here, and I use a Group1. I use this one because it already has a RESTful API endpoint. And I also create a new role from AWS policy templates. I also remember to delete this permission because I don't need it. I create a new API, a REST API, and the security, I chosen API key. And that time I create a Lambda function. I cancel because I already created it here, remotely control things. So I go to the code and I rewrite all the code lah. Basically, what the code does is to extract the body of the API request, I want to get the action type. If the action type is open window, then I will set the topic to window/control, and the message will be command open. If the action type is the closed gas valve, then the topic will be gas valve/control, and the command will be closed. This is to publish to the topic just now. And next, I need to go to API gateway. As I just said, the Lambda already created this API is with REST protocol. But I need to create the post method. I create method here, and then the method type, I choose post, and I choose the API key required for security purpose. And then next, I need to set the permissions by using the role. The role is already created for the Lambda function. This process execute user request is the role for the function. And I added this customer inline policy. You here create inline policy. This policy is to allow the Lambda function to publish to the specified IoT topics. And I put the topic window / control, topic gas valve / control. Then after this, everything is set already. Basically, I go to MQTT test client. Now it's testing. I subscribe to Windows / control. And now to test the whole thing, I go to Postman. I get the URL. I go and find the remotely control things invoke key, APIs remotely. I go to the stages, invoke remotely controlling post, and I copy this invoke URL and paste it. And then the header, I need to choose X API key and copy the API key here. Copy and paste it here. This is the correct key. I create another incorrect key. Just for testing, incorrect. For now, I choose the correct key first. And I go to the body and choose raw. And need to write the command. Yes, and now I send it. Missing authentication token. I need to set it to post. Sorry. And send. Action is triggered successfully. Now we check the topic, and we can see that Windows / control received this command. This means that the API did trigger the Lambda function successfully, and the Lambda function did process the API request. I can test again with a wrong API key. We can see the message forbidden, which means the API key validation working. Now I subscribe to the gas valve / control topic. The Lambda function will publish to the correct IoT topic. So now I change the, and then I send it, and I can see action triggered successfully. Now I see, the gas valve control will get the command closed. Meanwhile, the window control didn't receive the command. It will send to the correct topic. Now I open window again, send, action triggered successfully, and this command will be sent to window control. And if I put a wrong one, it will give the response invalid action type. So by changing the action type of the body, the function will send the command to the correct IoT topics. So the correct device will receive the correct message. That's all from me. Thank you.